In this lesson, we are going to learn a few of the applications of parabolas. Specifically, we're going to look at some problems involving satellite dishes and flashlights. In our first example, we're going to look at a satellite dish. Now, when you think of a satellite dish, you may think of, internet or watching TV, and basically you have a satellite up in outer space that is going to send signals in your backyard, and it's going to direct those signals to the receiver, and that receiver has to be located exactly at the focus point, otherwise you're going to get really poor reception. So it's very important when designing a satellite dish to know exactly what the equation is of the parabola that you're using and to be able to find the focus point. So in this particular problem, we have the cross-section of a satellite dish we know is a parabola. Signals from the satellite strike the surface of the dish and are reflected to a single point, the focus, where the receiver is located. In this problem, we know that our dish is 24 feet across and 18 feet deep. And what we need to do is figure out what position the receiver should be placed. Now, the receiver we know has to be located at the focus point. And if you think back to the problems we were doing in the previous lesson, to find the focus point, you have to have P. And if you're going to get P, first you've got to know what your A value is. So we need an equation for this parabola. So the first thing I'm going to do is I'm going to come over here and I'm going to sketch a little graph. So I'm going to draw an x-axis and a y-axis, and I'm going to take my parabola, my satellite dish, and I'm just going to place it right here in the center. I'm going to have it come down like this. And I'm placing the vertex of my satellite dish is going to be at the origin at 0, 0. Now remember, this thing is 24 feet all the way across, and we know that it is 18 feet deep at the center. If it's 24 all the way across and 18 feet deep, then this coordinate point here would be over 12 up 18, 12, 18. Likewise, the point on the left-hand side would be negative 12, 18. Okay, now we have a picture of what this parabola looks like. Let's go ahead and write our equation. So the equation of a parabola we've seen before, y equals a times x minus h squared plus k. And since we located this parabola at 0, 0, I'm going to go ahead and mark out h and k. We haven't shifted our parabola left or right. We haven't moved it up and down. So essentially, we really just have plain old y equals a x squared. Now, I need to know what a is, because if I can figure out what a is, then I can find p, which will tell me where my focus needs to be. So if I'm trying to solve for a here, then I have to have a number to plug in for x, and I have to have a number to plug in for y. That's where these coordinate points come in handy. A coordinate point has an x value and a y value. So I'm going to plug those numbers into this equation. For y, I'm going to plug in 18. And on the other side of my equation, for x, I'm going to plug in 12. Now let's go through and solve this. We know that 12 squared is 144. So I'm going to simplify this to 144a equals 18. To get a by itself, all I need to do is divide by 144 on both sides. Now I can simplify this fraction. I could even write it as a decimal, but for the time being, I'm just going to leave it the way that it is because this is not my final answer. I only need A so that I can go on to find P, because P is going to tell me where my focus needs to be. So remember the connection here. A equals 1 over 4P. I just figured out what A is, so I'm going to go ahead and plug that in. I've got 18 over 144 equals 1 over 4P. This is a proportion. I have the equal sign in the middle. So what I'm going to do is cross multiply and solve for P. So remember, when you cross multiply, the equal sign stays in the center. I've got 18 times 4P is 72P. And on the right-hand side, I have 144 times 1, which is 144. Now to solve for p, I just need to divide by 72 on both sides. And that's going to give me my answer. 144 divided by 72 is 2. P equals 2 is my answer. That tells me that the receiver should be placed 2 feet above the vertex. On the graph, we can see it here. This is where your focus point would be placed, your receiver, 2 feet above the vertex. Let's try one more example. This example is a flashlight. The inside of every flashlight is a parabolic mirror, and the light bulb has to be placed at exactly the focus point of the parabola so that its rays will reflect forward. So when you turn the flashlight on, the rays are going to originate from the bulb, and it's going to bounce towards the parabolic mirror and then beam straight forward. So no matter where it hits on that mirror, those light rays are going to be directed forward. So in this example, we're designing a flashlight so that the parabolic mirror is 204 centimeters across and 306 centimeters deep at its center. Our job is to figure out where the light bulb should be placed. And we know that the light bulb should be placed at the focus. So in order to find that, we need to know what P is. P is going to tell us how far away our focus is from our vertex. But we also know that in order to find P, first we have to find A, which means we need to know the equation of this parabola. So we're going to follow the same three-step process that we did in the previous example. I'm going to begin by drawing a graph. I'm going to have an x-axis and I'm going to have a y-axis. And I'm just going to take that parabolic mirror from my flashlight and I'm going to sketch it in the center of my graph. So I'm specifically placing it so that the vertex is at 0, 0. And I'm going to write all the information I know. I know that this parabolic mirror is 204 centimeters all the way across, that it's 306 centimeters deep in the center. So based on that information, I can write this coordinate point, 204, half of that would be 102. So if I'm trying to find this particular coordinate point on the right, it would be 102, 306. Same on the left-hand side. On the left-hand side, this would be negative 102 and 306. We're going to use this information to write the equation of the parabola. Equation of a parabola looks the same every single time. We have y equals a times x minus h squared plus k. But because we've centered our parabola at 0, 0, I don't need to plug anything in for h or k because I haven't shifted my graph left or right or up or down. So I'm just working with y equals ax squared. Now to figure out what a is, I have to have a number to plug in for x and I have to have a number to plug in for y. That's where these coordinate points come in handy. Every coordinate point has an x coordinate and a y coordinate. So we're going to plug the 102 in for x and we're going to plug the 306 in for y. So we'll have 306 equals a times 102 squared. I'm going to get my calculator here. 102 squared is going to be 10,404a equals 306. And we are trying to solve for a, so we're going to divide by 10,404 on both sides. This is going to give me a fraction. I could write it as a decimal. I could simplify it if I want to. But I know that ultimately this is not my final answer. This just tells me what the equation is for my parabola. To find the focus point, I need P. And remember the formula here, A equals 1 over 4P. P is going to tell us where to put our focus point. So since we just figured out what A is, we're going to plug that in. 106 over 10,404 equals 1 over 4P. This is a proportion. You have that equal sign in the middle. So what we're going to do is cross multiply. You're going to have 306 times 4P is 1,224P equals, I'm going to cross multiply again, 10,404 times 1 is 10,404. Now to get P by itself, I can just divide by 1,224 on both sides. If I use my calculator here, I've got 10,404 divided by 1,224 equals 8.5. So we need to put our light bulb 8.5 centimeters above the vertex.